Chapter 6, Lesson 1, Identify Linear Relationships. Linear relationships is lines. They are straight lines. You must have a constant rate of change. We have previously learned that it is the change in y over the change in x. We now call it the slope. If you look at the linear relationship, you can see that the change in x goes up by 2 each time, and the change in y go down by 15. Therefore, the slope is negative 15 over 2. You must have a constant rate of change to have a line, a straight line. A nonlinear relationship, the change in x goes up by 3, but the change in y goes up by 15, 33, 51. This is not constant. Therefore, it is non-linear. The second thing a linear relationship has to be is a straight line. It can be any straight line. I could draw any straight line through this graph, and as long as it is straight, they are all linear relationships. Nonlinear relationships do not create straight lines. You can see the example that is given. This would be nonlinear. This would be nonlinear. That would be nonlinear. Anything that does not create a straight line is not a linear relationship. Let's review. Linear relationships must have a constant rate of change and must be a straight line. Let's take a look at a few examples on the back. Let's see if example number 1 gives us a linear relationship. You must find the change in y over the change in x. Example number 1, it goes up by 1. The change in x goes up by 1. The change in y is 2, 3, and 4. Therefore, example number 1 is non-linear. There is not a constant rate of change. Let's take a look at example number 2. The change in y goes up by 12. The change in x is going up by 3. This one is linear. And now we need to find the constant rate of change, which is the change in y over change in x. We get 12 over 3. And remember, they must be simplified. They are treated like fractions. You can divide them both by 3. Therefore, the slope is 4 over 1. Do you have any questions at this time? Let's take a look at example number 3 in a graph. Number 3, as you can tell, it is a straight line, therefore it is linear. We still need to determine the constant rate of change. We need to find the change in y over the change in x. To find the change in y and the change in x, we are going to create a triangle above the line. Create a triangle above the line. The change in y is how many times you had to go up. And when you create your triangle, you want to pick 2 points on your line, and you're going to connect them by making a right triangle. The change in y is how much you have to go up. So we had to go up, and I'm going to count. You don't count the boxes. You make sure your numbers are counting. This goes up by 80, 40? So that's 40, 80, and 120. So my change in y from here to here is actually 140. So I'm going up 140. And since I'm going to go to the right, it means that it's positive. I'm going to go to the right 2. And remember, it does need to be simplified. So I have 140 over 2. These can both divide by 2 and give you 70 over 1. Your constant rate of change is 70 miles in 1 hour. I can use the y and x-axis labels to determine the miles and the hours if labels are given. Let's go back and review those steps. Step number 1, is it a straight line? Step number 2, you're going to draw a right triangle to connect 2 major points. On the line. Step 3, you're going to count amount going up. This is your change in y. Step 4, you're going to count amount left or right. This will be your change in x. If you go left, it's negative. If you go right, it's positive. Let's review that again since you couldn't see it. Number 1, step 1 is it a straight line? The first thing you want to do is make sure it is a straight line. Step 2, draw a right triangle to connect 2 major points. You want to make sure that your right triangle is actually above the line. Make sure you're always above the line. Count the amount going up. That is your change in y. Then you want to count the amount going left or right for your change in x. Let's see if we can practice this with example number 4. Step 1 says, is it a straight line? And for number 4, it is a straight line. So we know it is linear. Step 2 is to draw a right triangle to connect two major points above the line. It doesn't matter which 2 points you use. I'm just going to pick these two. Therefore, my constant rate of change is the change in y, which is how many I go up. So it looks like these are counting by 1. So 1, that's going up by 1, 2, 3, 4. Then you want your change in x, which is going left. Therefore, we know it's going to be negative. So those are still counting by 1, so that's 1, 2. Therefore, my constant rate of change is negative 4 over 1. Are there any questions at this time before we do example number 5 and 6? Well, let's take a look at example number 5. Example number 5 is linear. Step 2, you're going to draw a right triangle to connect two major points above the line. It doesn't matter, and if points aren't given, then find where your line crosses the two major lines. You don't want to be somewhere in the middle. You want to make sure that it has two whole number cross points. For your constant rate of change, you want the change in y, which is how many you're going to go up. I'm going to go up, looks like it's counting by ones on this one, so I'm going up 1, 2, 3, 4, 5. Your change in x is going right, therefore it's going to be positive, and it's going by 1, 2. Therefore your slope is 5 over 2, or your constant rate of change. How did you do on number 5? Do you have any more questions? Let's take a look at number 6. Is it a straight line? You are correct. It is linear. So I'm going to pick two major points. I'm going to pick this one and this one. And remember, you always want to draw your right triangle above the line. So I'm going to go this way and find my constant rate of change, which is the change in y, how much I go up. So it looks like I'm counting by ones again. So I get to go 1, 2, 3, 4, 5, 6, 7, 8. So I went up 8. The change in x is going left, which means it is what? You are correct. It is negative. I'm going to go negative 1, 2. I recognize that both 8 and 2 can be simplified by 2. Therefore, my constant rate of change is negative 4 over 1. Does anybody have any questions at this time? Remember, when you are determining the constant rate of change from a table, you find the change in y over the change in x, how much it is going by from each point. Make sure you simplify. To find the constant rate of change in a graph, follow the 4 steps that we have written down. Number 1, determine that it is a straight line. Number 2, make sure you draw a right triangle to connect two major points above your line. Step 3, count the amount you are going up by for the change in y. Step 4, count the amount you are going left or right for the change in x. And remember, if you go left, it is going to be a negative slope. Chapter 6, Lesson 3 is determining the slope, but it looks like we have already done that in the last lesson, so this is just going to be a few extra notes. Take a look at the types of slopes. You have a positive slope, which is going uphill. You have a negative slope, which is going downhill. You have a zero slope, which is a horizontal line. And you have a vertical slope, which is undefined. I have a little video to show you in just a minute. As a review, finding the constant rate of change, or the slope, in a table is the change in y over the change in x. The change in y, for our example, is +1. The change in x is +5. Therefore, my constant rate of change is 1 over 5. Let's take a look at using graphs to find the constant rate of change. And remember, the constant rate of change is still the change in y over change in x. We now add the words rise over run, but it is the same thing that we just talked about in the previous note, where we can draw. We know that first off, step 1, you want to make sure that it is a line, a straight line. Step 2, draw your right triangle above your line, connecting two major points. Your change in y is how many you go up. This one is going up 1. Your change in x is how many you go left or right. Since this one is going right 2, that means we do have a positive slope. Therefore, your constant rate of change is 1/2. Let's take a look at this other example. This example here is the same process. You're still going to make your triangle above your line. Your change in y is how many you go up. You're going up 2, that's 1, 2. You count boxes or numbers. This one's going left, so it's -2. Therefore, your slope is -1 over 1, or -1. Are there any questions about finding the constant rate of change or the slope of a table or a graph? Now let's identify the constant rate of change or the slope using equations. The slope is the coefficient, or the number that multiplies to the x. It's the number that is right next to the x. So on our first example, our constant rate of change is 3. We also call that the slope. Our second example, the constant rate of change is -1/2. We also call that the slope. Our third example, what is our constant rate of change? You are correct. It is -5. It is the coefficient, the number that is next to the letter. How about this next one? There is an invisible 1. If you never see, or if you don't see a number next to a letter, remember that there is an invisible 1. This is one of those invisible math situations. So we're going to write that 1 and tell you that that is the constant rate of change or the slope. How about the last one? What is the constant rate of change or the slope? You are absolutely correct. It is -3. Do you have any questions about finding the constant rate of change or the slope in equations? Now let's see if you guys can practice some of these on your own. I will be taking volunteers to come demonstrate how to find the constant rate of change or the slope from tables, graphs, and equations. Please begin to work while I set things up, and then I will start calling you up to show the class how to find the constant rate of change and the slope.